Welcome to the Data Hall YouTube channel. In this video, we are going to continue our discussion on the categorical variable regression. So in our previous video, we discussed how do we do a single categorical variable in regression in R and how do we create its margins and margin plot. In this video, we are going to discuss what if we have multiple categorical variable, how would we include them in regression, how would we create margins plot, and how do we interpret their values. So let's start with the packages. We are going to use the GG effect package. This is used for the margins and margins plot. And then we are going to use tidyverse package. This is used for data wrangling and for the ggplot, where we would use the visualizations to have a look at and interpret the results. So let's load these libraries and let's set this seed. You would also have to set the seed so that you can have the exact same results as I have, and we are going to generate this dummy data. So this is a data that contains different individuals, their age, their marks that they have scored in their last exam, the salary that they have, their gender, and their level of education. So we have categorical and as well as continuous variables in our data set. So let me show you the structure of this data. So we start with what if we have multiple categorical variable, how would we perform the regression analysis and how would we interpret it? So if you see, we have this gender and education as categorical variable, but from the perspective of R interprets it as a character variable. So from our perspective, these are not categories, this is a character variable. So what we need to do is first we need to convert it into factors, and for that we take the data and then mutate for each of these two variables. We convert them into factors. Factors is we have a whole video on how to work with factor variables, how to work with categorical variables. It is a way of telling Stata that this is not a character vector or character variable. These are different categories, and consider them as factor or categorical variable. So if I execute this and then do the structure of the data, then check the structure of the data, you would see instead of character, you would see that there are factors, and over here we have two levels. We have female and male. Now they are now coded as 1 and 2. And similarly, we have 4 level of education and they are coded as 1, 2, 3, and 4. So if I can show you the unique values in the education variable, we have bachelor's, master's, primary, and secondary. And the unique values in gender variable, we have female and male. So let's start with the simple regression. We use the LM function. We take our dependent variable, which is salary, use the tilde sign to separate the dependent and the independent variables. And the only independent variable we have is education. So we have already told that it is a factor variable. We do not need to mention that over here. And the data that we are going to use is the data set. So if we didn't do this code, this specific code, we would have to tell R that it is a factor variable using this code, right? So whether you do it over here like this or you do it over here like this, that is one and the same thing. So I have already done it. I do not need to do it, but that's fine. I have already written it. So we'll move forward with it. So if I execute this and show you the summary, you would see that we have master's, primary, secondary, and then we have the intercept. Now, how do we interpret this intercept? This is the predicted value of the omitted category. And what is the omitted category in this case? It is bachelor's. So what we say is that the predicted salary of a person who is employed with the bachelor's level of education, the predicted salary would be $3,082. This is the differential coefficient. These are the differential coefficient, and what it says is that we interpret them with respect to the omitted category. So the omitted category becomes the reference or the benchmark or the base category. So this means that as compared to bachelor's, a master degree holder would earn $38 more salary. Similarly, a primary education holder would earn $39 more salary as compared to the bachelor's, because that is the omitted category. And the secondary degree holder or the secondary education, the person with the secondary level of education would earn $17 less than that of the primary education, that of the bachelor's education, that of the benchmark category. So if you were to use calculate the predicted salary of the person with the master's education, we take the intercept and we add the differential coefficient, and that would give us the predicted salary of a person with a master's level of education. Now, if you look at this this regression, you would see that it can so shouldn't it be that the primary or master's degree should have been the base level? So we usually assign base level. A logical way is to assign either the smallest or the highest category as the base level. But currently what it does is, because there is no order, we haven't given any order, we haven't told the order to R. That's why it takes the base category as the first, using the first alphabet. So if it is the first alphabet is the lowest one, then it would take it as a base category. So because bachelor start with the B, and that is the smallest alphabet in all these categories, so it takes bachelor's as a base category. But that is not a good way of doing it. Let me show you the numerical values of all these education values. So if we go over here, we see that primary is assigned a value of 3, secondary is assigned a value of 4. Similarly, bachelor is assigned a value of 1, because if we sort them, bachelors come first, so it gets alphabetically, it gets the value of 1. Similarly, masters come second, so it gets the value of 2. But a better way is to give them order based on the level of education. So what we do is we define the level of education. So first level of education is primary, then secondary, bachelor's, and then master's. If I execute this, then what we do is take the education variable and then use the factor function and assign the levels that we have just defined. Now that way, the levels, then that way when we execute the regression, it would take the base category as the lowest category. So in this case, the lowest category is primary. So the interpretation would be same, the values would be different, but the interpretation is same. So the one with the bachelor's, sorry, the omitted category is primary. So the one with the primary level of education would earn a salary of 3,122, and a secondary degree holder or a person with a secondary education, secondary level of education would earn $57 less than the one with the primary level of education. Now this is a hypothetical data, so do not take that seriously. How do we change the base level? So let's say if I do not want to interpret it with respect to primary, I want to interpret it with respect to secondary. So what I do is I use a relevel function and change the level to the secondary, right? And then when I execute the regression, we would have an interpretation, or we would have the base category as the secondary level of education. Now that was the interpretation from this regression table. What if we wanted to visualize the results? So we would first calculate margins, and then we would use ggpredict function to calculate the Marginsplot, and to calculate the margins, and then use the ggplot to visualize the margins. So for that, first we would have to execute the regression. We have our dependent variable and our independent variable. Then we use ggpredict to calculate the predicted value for each level of education, because we have a categorical variable. And then we are going to use ggplot to take these marginal effect. If I can show you the marginal effect, we get marginal effect predicted values for each level of education, right? Remember, this was the intercept value. And then we take this marginal effect and calculate and use the ggplot to make a graph. Now remember, over here we set secondary as the base reference. That's why it is the first category over here. But if I can re-execute these levels and then make the graph again, then you would see that we would have, like, it would take the category, the graph would take the level of categories from the levels that we have defined. If we were to use if we were to study the impact, the relationship between a specific category instead of all these categories, let's just say we are just interested in secondary education and want to check its impact on salary, then what we do is let's take the data and convert all these into columns. So now we would have a column for each level of education, and it would contain either 1 or 0. So these are dummy variables. So if the level of education was primary, then this education primary column would have a value of 1. Otherwise, it would have a value of 0. Now we are going to run the regression only on education, and then we are going to interpret these results. So this is how we are going to perform when we have a single categorical variable, but there are multiple categories. In our next video, what we are going to do is we are going to discuss what if we have multiple categorical variable in our regression, and what if we have a categorical and a continuous variable in our regression. And then in our next video, we are going to look into two-way interaction and three-way interaction. So stay tuned to this channel. Do hit the subscribe button, do hit the bell icon, and thanks for watching this video.